In our last video, we looked at 4 important rules for working with signals in Godot. We covered why signals should communicate events instead of control behavior, how to name them properly, the signal up, call down principle, and what data your signal should carry. So now you should have a solid foundation for building cleaner, more modular systems. If you haven't seen it yet, I will leave a link to it at the end of this video. But as your project grows, a new set of challenges starts to appear. What happens when enemies, bullets, or pickups are being spawned in dynamically at runtime? What happens when dozens of different systems need to react to the same event? And what happens when a signal connection changes unexpectedly and your game starts behaving in ways you didn't anticipate? In this video, we're going to look at 3 more signal rules that will help you tackle those problems. We'll cover how to handle dynamically spawned objects, when to use a signal bus for global events, and when it makes sense to disconnect a signal completely. And finally, I'll introduce you to a very important programming concept called the single source of truth, or SSOT. It's a simple idea, but once you understand it, you'll start writing systems that are more reliable, easier to debug, and much more harder to break accidentally. So if you've ever found yourself wondering why a signal fired twice, why an object stopped responding, or why your project is becoming harder to maintain as it grows, this video is for you. I'm D, and this is D-Ragu Games. Let's get started. Now that our signal is carrying data, the next question is, what happens when we have multiple coins that all need to connect to the same coin-connected signal? To demonstrate this, I've made a few changes to the scene tree. First, I added an empty node called Score Manager and attached a Score Manager script to it. Then, as a child of the canvas layer, I added another control node called Label Control. Inside it, there are 2 label nodes, a label node for displaying the type of coin collected, and a score label for displaying the player's current score. I've also added 2 more coins to the level. Nothing complicated here. I simply duplicated the original coin and created a new script for each one. Each coin emits the same coin collected signal, but with different values for points and coin type. Now, you might be thinking that having multiple coin scripts all emitting the same signal could get messy. And while there is nothing inherently wrong with this approach, there is a cleaner and more scalable solution. But we'll get to that shortly. For now, let's focus on how we can receive and use the data being sent by these signals. To do that, let's look at the Score Manager script. The Score Manager script is probably my favorite script in this tutorial because it shows off some really powerful Godot features. First, we create a variable to store the player's current score, along with references to the score label and type label that will display the information on the screen. Inside the ready function, we get references to those UI elements. One really useful Godot feature is unique node names. By right-clicking on a node and selecting Access as Unique Name, you can reference that node directly without having to worry about long node paths. It makes your code much cleaner and easier to maintain. Now for the really interesting part. Because all of our coins belong to the coins group, we can use getTree.getNodesInGroup to collect every coin in the level and store them in an array called all coins. Then, using a simple for loop, we iterate through the array and connect each coin's coin collected signal to the same onCoin collected function. This means we don't have to manually connect every coin in the editor. Any coin that belongs to the coins group will automatically be picked up and connected when the scene starts. When a coin is collected, the onCoin collected function receives the point and coin type values that were passed through the signal. The function then adds the incoming points to the player's current score and updates the score label. It also updates the label type to show which type of coin was collected. This is a great example of why passing data through signals is so useful. The Score Manager doesn't need to know anything about the individual coin scenes. It simply listens for the signal and uses whatever data is provided. But earlier I did mention that there was an even better solution for handling communication between systems that aren't closely related. And that's where event buses, also known as autoloads, come in. Let's take a look at how they work next. At this point, it's worth talking about autoloads. sometimes called singletons in Godot. An autoload is a script or node that Godot automatically creates and places at the very top of the scene tree before any other scene is loaded. Because it lives at the root of the tree, it stays active for the entire lifetime of your game, even as you switch between scenes. This makes autoloads extremely useful for things that need to be accessible from anywhere in your project. So, you can use them to store persistent data such as players' score, inventory, or health. They are also great for maintaining global systems like an audio manager, quest manager, or dialogue system. Many developers also use them to handle scene transitions, save and load systems, or loading screens. For this example, we're going to use an autoload for a global signal hub, often called an event bus. Instead of every coin needing to directly connect to the score manager, we'll move the coin collected signal into a globally accessible autoload. This allows any coin in the game to emit the signal, and any system that cares about coin collection can listen for it. The result is even less coupling between game systems and a much cleaner architecture as your project grows. And setting this up is surprisingly simple. Let's take a look. First, we need to create the autoload. I'll start by making a new folder called autoloads, and inside it, I'll create a script named Signal Hub. Next, I'll go to Project Settings, Globals, Autoload, browse for the Signal script, and click Add. This makes the script globally accessible from anywhere in the project. Now let's take a look at the script itself. The entire autoload only needs one thing: the signal we were previously using in each coin script. There's also one additional line that tells Godot to ignore any unused signals warnings, just to keep things clean. With this in place, the signal is now global. That means we no longer need to define it inside every coin script. Instead, each coin can simply emit the shared signal like this. We pass in the same data as before, points and coin type, but now everything is routed through a single global event hub. This removes duplication, makes the system easier to scale, and keeps all game-wide events centralized in one place. To tie everything together, we'll go back to the score manager. Because Signal Hub is a single global autoload, its signal only needs to be connected once, no matter how many coins exist in the level. This means we can remove the entire setup where we loop through all the coins and manually connect each one. Instead, we simply connect directly to the global signal like this: signalhub.coincollected.connect, and pass in onCoinCollected. And that's it. Everything else in the score manager stays exactly the same. Now, whenever any coin emits signalhub.coincollected, the score manager automatically receives it and updates the score and coin type accordingly. With this setup, we now have a clean, centralized, globally accessible system. But it raises an interesting question. What happens when we need to disconnect from a signal? And that's what we're going to look at next. While Godot automatically handles signal cleanup in many cases, manually disconnecting signals can still be very useful in more complex systems. But what if you want to temporarily disconnect and reconnect a signal for an object that remains in the scene? To demonstrate this, I created a ghost coin that periodically fades in and out of existence. The ghost coin scene is built like all the other coins, using a Node 2D, Area 2D, Collision Shape 2D, and Sprite 2D. The main difference is the addition of a timer node, which controls how long the coin stays visible and faded. The timer is set to auto start with one shot disabled, causing it to fire repeatedly every 2.5 seconds. Whenever the timer times out, it triggers a tween that smoothly changes the sprite's 2D alpha value between 1 fully visible and 0.2 faded over 0.5 seconds. When the coin enters its faded state, I disconnect the body entered signal using area.bodyEntered.disconnect and pass in the onArea2D bodyEntered function. This prevents the player from collecting the coin while it's faded out. That said, there's arguably a simpler and better approach. Instead of disconnecting the signal, you could simply disable the collision shape by using collisionShape.setDeferred disabled true. And to be honest, that's probably what I would use in a real project. I mainly wanted to experiment with manually disconnecting and reconnecting signals signals to see how it would work in practice. What do you think? Would you disable the collision shape, disconnect the signal, or are they effectively solving the same problem? Now, let's take a closer look at the script. When the coin enters the faded state, we disconnect the area.bodyEntered signal so the player can no longer interact with it. To do this safely, we first checked whether the signal is actually connected. This is important because calling .disconnect on a signal that isn't connected will cause a runtime error in Godot. But by using if area.bodyEntered.isConnected and passing in onCoinArea2D body entered, we can safely disconnect the signal only when it's already connected. One advantage of this approach is cleaner state management, and we don't need an extra variable such as var isGhost equals false. Instead, the coin state is determined by whether the signal is connected. If the signal is connected, the coin can be collected. If it isn't, the coin is effectively inactive. But this is the interesting part. Even when the coin is faded, the area2D can still detect the player passing through it. However, because the body entered signal has been disconnected, the onBodyEntered function is never called. In other words, the collision is still happening, but the gameplay logic that responds to that collision has been temporarily switched off. The toggle system I'm using here is based on a very important programming concept called single source of truth, often abbreviated as SSOT. The idea is simple. A piece of information should exist in only one place. If any part of your code needs to know that information, it should check that one source rather than maintaining its own separate copy, because duplicate states can easily fall out of sync and create bugs. Think of it like having two clocks in your house, one on the wall and one on the microwave. If they show different times, which one do you trust? Without a clear source of truth, you really can't be sure. The same problem appears in game development all the time. That's exactly what we're trying to avoid with our ghost coin. Instead of storing the coin state in a separate variable, we're using the signal connection itself as the source of truth. If the signal is connected, the coin can be collected. If the signal is disconnected, it can't. There's only one place to check, one state to manage, and far less chance of things getting out of sync. Let's see what that looks like in practice with the ghost coin example. In this version, we create a custom variable called isGhost to track the coin's state, while also managing the signal connection separately. At first glance, this seems perfectly reasonable. The problem is that now we have two sources of truth, the isGhost variable and Godot's internal signals connection state. And that's where things can go wrong. Think back to the two clocks analogy. If one clock says 3 o'clock and the other one says 3:05, which one is correct? The same issue can happen here. Imagine later you add a magic spell that forces all ghost coins to become solid. The spell script reconnects the signal using bodyEntered.connect on bodyEntered, and the coin is now collectible again because the signal is connected. But what if that spell doesn't know about the isGhost variable? The signal says the coin is solid, but the isGhost is still set to true. Now, the two sources of truths disagree. The next time the timer fires, it checks isGhost, assumes the coin is still a ghost, and executes the wrong logic. Suddenly, the coin's behavior becomes unpredictable because its state is no longer consistent. This is the danger of maintaining duplicate states. The more places you store the same information, the greater the chance that one of them will be updated while the other is forgotten. Eventually, they drift out of sync and bugs start appearing. Now, in our example, the timer doesn't need to know why that happened or track it separately. The next time it ticks, it simply asks, is the signal connected right now? If yes, the coin is active. If no, it's a ghost. This happens because we're always querying the real underlying engine state instead of a manually maintained variable. So it becomes impossible for the logic to drift out of sync. There's no second clock, there's no conflicting state. There's just one truth coming directly from the system itself. If this video made you stop and think about how you're learning Godot and not just what you're building, then you're exactly who this channel is for. I make videos for developers who want to understand their code and have the discussions that tackle the difficult topics. So if that sounds like you, hit subscribe. You'll feel right at home here. And before you go, answer this in the comments. Are you using signals in your projects? And which of these tips did you find most interesting? Until next time, happy coding, keep experimenting, and I'll see you in the comments. This has been Diragu Games.